Hey friends, welcome to our first lecture of Laplace Transform. Today we are going to learn about the introduction to Laplace Transform and definition. So let's start it. Introduction. By using a particular type of an definite integral as an operator, a new function can be defined. The function is nothing but our Laplace transform. Okay, when we are using a Laplace formula to any of the function, the function should satisfy two conditions. First one is piecewise continuity and second one is exponential order. If you need detailed video on this, you can mention on my comment box. So let's start with the definition. Definition is Laplace of f of t equal to integration 0 to infinity e raised to minus st dot f of t dt. We can say Laplace of f of t is also same as phi of s. Let's try to solve an example by using the formula or definition. Find a Laplace of function f of t equal to 1. Here the function is 1. Okay. Solution. First of all, we write the definition. By definition, what is the definition? Laplace of f of t equal to integration 0 to infinity e raised to minus st into f of t into dt. F of t to dt, right? Okay. Laplace of 1. Here we can change the f of t by 1 because the question is given this 1. So f of t is equal to 1 is equal to infinity 0 to infinity e raised to minus st. F of t is 1, so we will write here 1 dot dt. Okay, so there is no value of 1, so that's a unity. We can write as e raised to st into dt. Okay, now as we all know the formula, okay, sorry, it's not okay, we know the formula as integration of e raised to x dx is nothing but e raised to x. Okay, but this is here e raised to minus st means it's a compound function. So how will we write it? E raised to minus st. So what is the amount with this? S. So we will write it minus s because it's an integration. So put out the limit 0 to infinity. Now we will go putting the value of infinities or the limits e raised to minus s infinity, because that is with respect to t, so we are replacing the value of limit with the t. So e raised to minus s into 0, so it's for example, but it's shown minus s. Okay, e raised to minus s infinity upon minus s, or it is simply plus because minus plus gets e raised to minus 0. Okay, so there is one thing to remember in this chapter is e raised to minus infinity is always 0. Remember this, e raised to 0 is always 1. This two formula is going to help you in entire this lesson, so please remember this. So e raised to minus infinity, this whole term becomes 0. Okay, plus e raised to 0 is equal to 1, so 1 upon s. So final answer what we get is 1 upon s. So what we conclude is Laplace of 1 is 1 upon s. These are the some standard formula that has derived from this by the definition itself. I'm getting solve it and try to solve some of the formula by using. Okay friends, try to solve some of the problems that based on the formula definition of the Laplace. So these are the simple problem based on the last previously, you can just refer it. And if you like this video, please press the like button. If you have some suggestion, then comment me down. And finally, subscribe to my channel SB Preparation.